What we're showing here is robotic technology for cataract surgery. Cataract surgery is the highest volume surgical procedure in the world, restoring sight to 20 million people every year. But there's still a large range of outcomes in this surgery due to the small size of the tissue being manipulated. So the idea is that the surgeon has to go in and scrape away a cloudy lens, which is about 10 millimeters in diameter, and replace it with a new plastic lens. And it's currently done by hand using tweezers under a surgical microscope. Now, this is an area that seems ripe for the sorts of benefits that robotics can provide. Motion scaling, tremor reduction, image guidance to avoid sensitive tissues. But building a robot on that size scale is very difficult. But what we're showing here is technology that overcomes many of those technical limitations that prevent you from building a robot that, for example, could access the eye. Traditional surgical robots operate on a long, straight instrument where to get motion on the inside of the body, you also need to have large motion on the outside of the body. So not only does the robot take up a lot of room, but the instruments moving around take up a lot of room. So what we've done is designed a system with a parallel mechanism that does not move on the outside of the body, and yet still gives full performance moving the actuation and the articulation to the inside of the body. So we're showing a robot that is both small on the inside, small on the outside, able to easily integrate with the current operating room workflow. In this 1.8 millimeter diameter robot, there's a 1 millimeter working channel. We have 4 mechanical cables that are passing through 150 micron holes, 110 micron diameter cables that provide the actuation. We've also designed a low friction mechanism so to be able to provide the capability of force feedback. And so forces interacting at the tip of the instrument can be relayed back to the surgeon's hands, providing the sense of touch. And this is a capability that is not in current surgical robots. This demonstrates the fact that robotic technology can apply to a size scale that has never been addressed before. So this not only enables robotic manipulation for things like cataract surgery and eye surgery, but I can see it enabling a number of different neurostimulator implants, early cancer manipulations, flexible endoscopic manipulations that have never been able to be addressed before because the mechanisms are just too big.